So, I mean, we can do any of these. I was going to do number 7, but I remembered odd problems, you can find solutions at calcchat.com. So, how about I do, let's see, let's do number 8. Now, we're going to work this out using trapezoidal and Simpson's rules. And so let's start with the trapezoidal rule for n equals 6. There we go. So in this, a is 1, b is 4. So we have b minus a over 2n. And then you got all this stuff on the inside. So that's going to be 3 over 12, right? Or 1/4. So we're going to have 1/4 times, alright, so the distance, if n is 6, the distance from 1 to 4, and you might want to think about it like it's on a number line or in your x-axis, the distance from 1 to 4 is 3. So you have 1 there, and let's say you have 4 here. So if n is 6, you have to say 3 divided by 6. So the change in x is 1/2. So that's going to be 1, then we're going to have 3/2, 2, 5/2, 3, 7/2, 4. Alright. And so with the trapezoidal rule, right here we're going to have f of the first x, which is 1. So f of 1 plus, now you don't put any coefficient in front of the first one, but in front of the second one you start with the 2's. So 2 times f of 3/2 plus 2 times f of 2 plus 2 times f of 5/2 plus 2 times f of 3, run out of room there, come down here, plus 2 times f of 7/2, and then with the last one you have no coefficient, so comes f of 4. Some students forget, what is f? Well, it's this, that's your function right there. So f of x is 4 minus x squared. Okay. So now I have to do all these calculations. So this is 1/4 times, alright, f of 1. So if I plug a 1 in there, I have 4 minus 1. That's 3. Plus 2 times f of 3/2. 3/2 squared is 9/4. So 4 minus 9/4. That's 16/4 minus 9/4, or 7/4. Plus 2 times, plug in a 2. 2 squared is 4. So 4 minus 4 is what? 0. Plus 2 times, plug in a 5/2, and that's going to be 25/4. So 16/4 minus 25/4 is negative 11/4. So we might want to be careful on this one. We start getting negative numbers. Alright. But anyway, let's just keep going. So plus, running out of room again, 2 times, I plug in a 3. 3 squared is 9. 4 minus 9 is negative 5. Alright. Plus 2 times, plug in 7 halves. 4 minus 7 halves squared. 7 halves squared, that's 49 over 4. So 16 over 4 minus 49 over 4. So that's going to be 33. Negative 33 over 4. Okay. And the last one is plug in a 4. 4 minus 4 squared, so that's going to be 4 minus 16, or negative 12. Okay. Now we need to calculate that. Alright. So I think this one is negative 9 over 4. And let's keep going. Almost done with trapezoidal rule. We got 1/4 times. Now we need to do all this calculation. We can do all that calculations pretty quick, hopefully. 3 plus, it's going to be 7 halves. And then minus 9 halves. Minus 10. Minus 33 halves. Minus 12. Okay. So that's going to be 1/4 times, alright, so we got negative 22 plus 3, that's going to be negative 19, and then that's going to be negative 2 halves, negative 35 halves, and so that is 38 halves, and so 38 and 35 would be 70, negative 73 halves. I'm about to run out of room here, so that's 1/4 times negative 73 halves. Alright, so I have negative 73 over 8. Alright, so I just want to see what it is here. Negative 73 over 8. It's going to be a negative 9 and a 6, or 9.125. The way that I can tell if I'm close, I mean, this is my first time to work this too, is I can now take and find the definite interval. And so I'll know if my approximation is close. I know that may sound a little counterproductive. Why would we be doing approximation if we could actually find the actual? And that's just because it's cool. That's why we're doing it. Because it's the trapezoidal rule and it's cool. Alright, so integrate that. It's really laughable how much faster you can do it with a definite integral. But that's going to be 4x minus x cubed over 3. 4x minus x cubed over 3, evaluated from 1 to 4. So that is 16 minus 64 over 3 minus 4 minus 1/3. Alright, so that's 48/3 minus 64/3 minus, and then 4 minus 1/3 is 3 2/3, which is 11/3. Alright, so that will be 16, negative 16/3 minus 11/3, or negative 27/3, which is negative 9. So the actual area is negative 9. Using the trapezoidal rule, I got negative 73/8, which we said was negative 9.125. So that way, I mean, I'm pretty close. I know that I'm pretty close there. So that is good news. That means I probably didn't make any bad mistakes. The good thing about the next method that I use is I have some of this work that I can go by. It may not be exactly the same, but it will be a little bit the same. That'll help me or save me a little time. Okay, so let's do the same problem with Simpson's rule. The outside is b minus a, so that's going to stay 1 over not 2n, but 3n. So 3 times 6. So that's going to be, and it wasn't 1 on top, it was what? It's b minus a. Don't always just go along with what I say. I may be wrong. So that's 4 minus 1. So that's still 3. So that's on the outside. So you see there's going to be a 1/6 on the outside. And then remember this pattern on the inside for Simpson's rule. It's 1 and then what? 4, 2, 4, 2, 4, 1. Alright, 1 and then 4, 2, 4, 2, 4, 2, so on and so forth. And the last term has to have a 1 in front. Alright, so we'll be able to use some of these values here, maybe not all of them. That's okay. Because we're plugging them in the same function. So let's see. F of 1 plus, this one's going to be different because you got to say 4 times f of 3/2. So you can use your other work though. If you do a lot better job than me and are a little more detailed, you can definitely use your other work to help you work this one. So plus 2 times f of 2 plus 4 times f of 5/2 plus 2 times f of 3 plus 4 times f of 7/2 plus, this is where there's nothing, just f of 4. Okay. Now, since I'm very confident that my first answer was correct, I'm saying that, and it was probably not, but I think it was, pretty sure. What you can do, what I figured out, and it wasn't like a miraculous theorem that I come up with or anything, instead of, if you're just multiplying this by 4 instead of 2, see what answer you got. Like we got right here, the second one was 7/2. So you're multiplying it by 4 instead of 2, so just multiply that by 2. But you've already, this is the answer multiplied by 2. If you need to multiply it by 4, you just multiply it by 2 more. So this first one was 3. This we're multiplying by 4 instead of 2, so multiply that by 2, you get 7. This one right here is the same as what we had, so that's minus 9 halves. Got to be careful to not correspond these differently. This one you're multiplying by 4 instead of 2, so it won't be a negative 10, it'll be a negative 20. This one here, oh. Let me make sure I haven't gotten off. I may have, because look at this term right here. This threw me a sucker punch, didn't it? Because this one was 0. That was the third term. So, guess what? This third term right here is supposed to be... See, I should have put that 0 in here anticipating that. Then I would have seemed a lot smarter than I really am. So this is the third term, the 0. I should be just reworking it all out, but I'm trying to save a little time, which now is starting to cut into more time. But so that this third term right here is 0. Why? Because when you plug in this 2, you get 4 minus 4 in the function. So I'll just put a plus 0 there for good luck. Then this one is times 2. Well, that kind of works out okay because it gets rid of that fraction there. So that's minus 9. This one is the same. It's this one. So that's minus 10. This one you multiply by 2. So that's minus 33. And this one right here is minus 12. Alright, so now let's put all those numbers together. I'll put those together in the calculator. So the first two are 10, minus 9, minus 10, minus 33, minus 12. So I got a negative 45. Alright, so this is going to be negative 45 over 6. And that's what? Negative 9. So that gave me exactly what I wanted. Negative 9. That was what we got with the definite integral. Wasn't it? Yeah. And that's what we got with Simpson's rule as well. Yeah, spot on so much that I messed it up. I was thinking 54, but I don't feel as bad because I just wrote it down wrong. Yeah, so it is negative 9. It works out good.